Alright, so in this video we're going to identify the parts of an exponential function. So we're going to evaluate functions, we're going to determine if they're exponential or linear, we're going to find initial value in base from a function, and we're going to write the equation for an exponential function. But first we are going to evaluate them. So when you evaluate, that means you're going to substitute in a number. So I need to substitute 3 in for x, and so everywhere I see that x, I'm going to put a 3. So I would have h of x equals 4 times 7, but I need to raise it to the third power. Okay, how you would type that in your calculator is with this little arrow button. So notice, I'm going to show you a calculator right now. So here is what your calculator looks like. The raise button is right here underneath the clear button. So you're going to press this button when you want to raise it to a power. So for example, on this last one, what you would type in the calculator is a 4. You would say times 7, and then you would raise it to the third power. Once you type that in the calculator, let's do that together. So 4 times 7 and raise it to the third. You should get 1,372. So if you did not get that, you should raise your hand and I can show you how to type that in the calculator. Otherwise, let's try this last one. I need to plug in 5 everywhere I see an x. So I'd start off with 3 times 8. That 5 is up there as an exponent plus 2. And then I need to come down and do subtract 5. So if you were to type that in the calculator, you would just want this 5 plus 2 raised. So what you could do is, what is 5 plus 2? Well, it's 7. So this is the same as 3 times 8 to the 7 minus 5. So you would type that in the calculator, 3 times 8, raise it to the 7. You're going to have to hit the arrow to go down on the same level and then subtract 5. So you should get 629,1,451. Okay, so if you did not get that, again, raise your hand so I can show you how to type that into the calculator. All right, so that's how you evaluate a exponential function. Now we're going to see determine if it's linear or exponential. So I've got two tables. I've got a linear table and I have an exponential table. Remember, linear is going to add or subtract, which means exponential is going to multiply or divide. Okay, so if I notice my table went from a 3 to a 6, that means they added 3. So let me continue with that pattern. 6 plus 3 is 9. 9 plus 3 is 12. So if that table was linear, they'd be adding a constant number each time. For exponential, how do you get from a 3 to a 9 by adding or subtract, or not adding or subtracting, multiplying or dividing? They would be timesing by 3. So they times by 3 here. So you're going to have to do 9 times 3 and get 27, and again times by 3 to get 81. So some similarities and differences. They're both going by a constant number, so notice they are both going up by 3, but again, linear is adding or subtracting while exponential is multiplying or dividing. Also notice exponential gets really big really fast because you are multiplying, whereas linear is not going to get as big as fast. Okay, so that's how you determine whether something is linear or exponential in a table. So let's go to the next page. Calculator. So I just talked about this for you right here. We completed that table. Here's another picture. A linear function we know is going to be a straight line. Exponential is going to have a curve, and it's going to curve up or it can curve down. So for example, this can also be a graph. It could start up and go really, really down like that. So it's either going to go up really fast with the curve or it's going to go down really fast with the curve, which would be exponential. So let's look at this table, and I want you to determine whether it's linear, exponential, or neither. So press pause, see if you can tell which one is linear, exponential, or neither. So when you looked at these three tables, we can look at this one. So notice maybe they added 3 right here, but then again we can see that 3 plus 3 is not 12. So they weren't adding. To check multiplying, 3 times 4 is 12, but 12 times 4 isn't 27. So that is why this table was neither, because they were not adding or subtracting or multiplying or dividing. Between these two tables, we could have thought they were adding 2 right here, but you would have noticed 4 plus 2 is not 8. So then that means they were multiplying, and so they are multiplying by 2, because 8 times 2 is 16, and so on. So that was exponential because they were multiplying. The last one, notice that from a 1 to a 4, you can add 3, and then negative 2 plus 3 is a 1. So they were adding in this case, so it was linear. Okay. Moving on, determine whether the functions are linear, exponential, or neither, and justify your reasoning. So why don't you try these on your own? Try these 4 graphs and these 4 equations. Press pause and we'll go over the answer. So for these graphs, the first one is neither because a U-shaped curve is not exponential. Same thing for h of x. This is neither exponential. So exponential is going to go up really fast or down. It's not going to go both ways. So that's why this graph was exponential. Over here we have a line, so that is linear. Down here with equations, so notice this is y equals mx plus b. So this is a linear equation because of y equals mx plus b. So these are probably confusing for you. Exponential has to have the x in the exponent. Okay? So notice on h of x and j of x, we have exponents of a 2 and a 3 and a 2, but to be exponential, the x has to be in the exponent position. Okay, so that's why these two were neither. All right, let's get into writing the equations now. So your initial value and your base or your growth factor are the two things you need. So your equations are always going to be a times b to the x, where this a is your initial value and the b is the growth factor. It's also called the base. And remember, that's initial value. Okay, so this is the generic form of an equation. So the first thing you have to find is the starting point. The second thing you have to find is the growth factor. What are they multiplying by each time? All right, so let's take a look at this. With a graph, your initial value is right here. So your initial value is where it crosses the y-axis, just like a line. So your initial value is a 2. To see what they're going up by, you would go to a 1. And so how do you go from a 2 to a 4? Multiplying would be times by 2. So your growth factor is going to be a 2. So the equation would be y equals 2 times 2 to the x. Okay. Notice we do not say 2 times 2 is 4x. You cannot do that, okay? So you have to leave them with the initial value out front and the growth factor next to that. Let's look at this table again. So we've seen this table before. We saw that they are timesing by 2 each time. So your growth factor would be a 2. Notice they gave us the initial value. That's always when x is 0. So again, the equation will be 2 times 2 to the x for that table. And then on this last one over here, they gave us the equation. And so this 5 is your initial value, and that 6 is the growth factor. All right, So that's a little bit about the equation of exponential functions. So press pause if you are still writing, otherwise we're going to move on. So here is an example. It says find the initial value, the growth factor, and then write the equation. Okay, so first off, here is our initial value. This graph is going by ones if you can't tell. So the initial value is at a 2. To find the growth factor, I'm going to go to where x is a 1, and so that would be at a 6. So you would ask yourself, how can you go from a 2 to a 6? Think about multiplying, not adding. So that would be 2 times 3. So your growth factor is going to be a 3. So once you have those two things, you can write your equation. So it'd be y equals 2 for the initial value, 3 for the growth factor, and then you put an x on top. Okay? So that's how you find it from a graph. Again, the initial value is probably the easiest thing to see. It's where it crosses the y-intercept. To see how much it's increasing by, go over 1, find the point, and then ask yourself, how can you multiply to get that number? All right. Example 4, I need to write the equation from a table. So same thing, I need to find what we're multiplying by. On this one, I can see that they're timesing by 3 because I know 5 times 3 is 15. And then they gave you your initial value. So your initial value is going to be a 5. And then the growth rate is a 3. So when you write your equation, it'd be y equals 5 times 3 to the x. All right? On number 5, it wants to find the initial value and the base. Remember, base is the same thing as the growth factor. So that would be my initial value. So my initial value is a 4. My base is the number next to the x. So my base is going to be a 7. Okay? All right, so why don't you try example 6 on your own? I want you to write the equation from the graph and from the table. So you're going to need to find the initial value and the growth factor first. So press pause and write the equation. In this example, I found the initial value to be a 1. Then I went over 1 and I found a point at 4. So I would ask myself, how can I get from a 1 to a 4 multiplying? So 1 times 4 is 4. So that's why your growth factor is a 4. So my equation would be y equals 1 times 4 to the x for the graph. On the table, I had a little bit of trouble because I forgot 6 times what's 54. So what you can do is pick a number and divide it by the one before it if you know it is exponential. So I did 54 divided by 9 and I got 6. So then I checked myself and I did 9 times 6 is 54. I did 54 times 6 and I did get 324. So I knew my growth factor was a 6. The initial value, they gave it to us because it's when x equals 0 and it was 9. So your equation would be y equals 9 times x times 6 to the x power. All right. So that's it. We're done. Wow, that was quick. So if you have any questions on exponential functions, writing them or anything, let me know. Otherwise, it is your time to practice. So thanks for watching.